Hello everybody, my name is Trevor Parator, and my paper and presentation is going to be on the physics of judo. Judo is my sport. I picked judo because when I was younger I did a ton of judo, and I also did a little bit of Brazilian Jiu-Jitsu. But I picked judo because physics is heavily involved in the sport of judo. As a matter of fact, you'd be hard-pressed to find anybody who could describe what's going on in judo without using some pretty basic physics concepts. So I hope you guys enjoy. I had a lot of fun writing the paper, doing some research, learning some new words actually that I've not heard used in the dojo before. So without further ado, this is the physics of judo. That was terrible. Anyway, okay. So judo means the gentle way. It's a Japanese spectator sport that was born from an older martial art called Jiu-Jitsu in 1882. Jiu-Jitsu was a martial art utilized by samurai when they lost their swords. Well, why wouldn't they just punch other samurai if they lost their swords? Well, silly goose. If you try and punch somebody wearing armor, it doesn't really do that much damage. However, if you were able to throw them, now that can do some damage, especially with the added weight of their own armor. So that's where we get judo from. Judo is nowadays not used by samurai because you'd be hard pressed to find a samurai anywhere. Now it's an Olympic spectator sport, popular all over the world. So let me describe a little bit what it is. If you're unfamiliar with judo, the way that you win is actually by obtaining one single point. That's all you got to do to win. You got to make 1 point. And you can get this point by executing a perfect throw. No pressure, right? It's just got to be perfect, beautiful. So how does one define a perfect throw? Well, basically, if you're to throw your opponent and they land flat on their shoulders or on their back, and throughout the entire throw you have shown complete dominance and superiority of the throw, you get the point, more often than not. Another way that you can attain ippon is by submitting your opponent, but that's not something that we're going to talk about. We're specifically interested in the physics and the mechanics of throwing someone. So here's an example of what it looks like to get an ippon, or 1 full point. You'll notice he steps in, and boom, the guy in the white, we call gi, as his shoulders hit the mat. And whoa, now this time the guy in the blue, his shoulders hit the mat. And we'll watch one more, just because these are fun. And wow, okay. That one was a little crazy, but the guy's shoulders definitely touched the mat. Alright, so there are different components to a throw. It's not just, some crazy, wild, goings on. It's not like WWE or anything. This stuff is calculated. So the components of a throw, there's 3 different kinds of throws. There's ashiwaza, which is a foot technique, or like sweeps, reaps, leg picks. Teiwaza, which is a hand technique, which is where you basically use your hand or your arm to cinch it in, and you use that as a torquing device. Think like a wrench. You use the wrench to torque. Koshiwaza is a hip technique. You use your hip, which is basically where your center of gravity is, where anyone's center of gravity is, and you use it as a fulcrum to throw your opponent. Applying torque and rotating them over your center of gravity. There's also 3 phases. And yeah, I know it's a lot of words coming at once, a lot of foreign words, but don't worry, there's going to be a quiz at the end. You're going to do horrible. Fine, So there's 3 phases: Kuzushi, Sukari, and Kake. Kuzushi is the introductory phase. If you look in the bottom right, this is the linear acceleration of taking a step forward or taking a step back, or from side to side. There's a Sukari phase, which is the setting into position, placing your center of gravity in the place required for your throw, be it ashiwaza, teiwaza, or koshiwaza throw. And then there's the final phase, which is the part where you get to throw somebody, and that's the acceleratory phase. Why is it called the acceleratory phase? Obviously because they're accelerating. So there are additionally 2 more kinds of throws: coupled and lever throws. I got this from Attilio Sacrapanti, who is a professor emeritus in Rome. He is a biophysics professor whose research interests specifically are specifically centralized around judo, because he himself is a judoka, or somebody who practices judo. So what's the difference between a coupled and a lever technique, Trevor? Coupled techniques are ones that cause rotation around the uke, or the person who is being thrown, around their center of gravity, and lever techniques are rotation around the tore's center of gravity, and a tore is somebody who's doing the throw. So if you look in the bottom left, the tore would be the person in the blue, and the uke would be the person in the white, and this is an example of a coupled throw because he's using the the tore is using his leg and the person's arms to torque them, and additionally he's using his legs to kick up, causing an inelastic collision, which helps to throw the uke over. And in the bottom right, it's basically a levered action. The picture's kind of bad, but basically he's using his leg as a point below the uke center of gravity and throwing them around that. So now, lever techniques. These rely upon contact between the two bodies, typically above or below the hip, where the competitor's center of gravity is located. Here is the formula for center of gravity. Since I say it so much, I might as well just put math in there. CG equals h divided by 2, so this is basically around the waist of a person. Once the bodies make contact, this can be viewed as an inelastic, not elastic collision, and that impulse that's felt right there immediately at the collision, we'll talk about later, lends to the power of the throw itself. And as they torque around the center of gravity, they connect with the ground after a free fall period. A couple technique is an applied force to the frontal and or sagittal plane. Sagittal plane refers to the middle and everything in reference to the middle, so the left side or the right side of the uke, which is the person being thrown. Ashiwaza. Ashiwaza techniques are almost always coupled techniques because they involve the feet and torquing. So they have to apply force to the front with their feet normally as they torque the uke, causing a rotation and moving on into the acceleratory phase. So coupled moves are often referred to as reaps, sweeps, leg picks, or sacrifice throws. Sacrifice throws, not something we really talk about in the essay because they're kind of crazy. They're sacrifice throws. You basically pull the uke in a direction where you want them to go, and you drop to the ground as fast as you can, and you use that momentum to complete the rotation. So another key component of a throw is where the linear and angular acceleration are and how they connect to the power of a throw. So how do you know what throw is going to deal the most damage? This has been done actually experimentally by Imamura et al. I have it referenced here. These are all going to be on my reference page. But so basically, linear acceleration means when you're moving forward or backward, side to side. The angular acceleration is when the uke or the tore is torquing onto the uke and the uke is rotating through the air. That is the angular acceleration. Remember, torque is a force that causes a rotation. So when the tore is applying a force to the uke, causing them to rotate, that is referred to as torque. So the time distance between the linear and angular acceleration is on average less than 1.5, according to this Eris guy. And calculating the difference between those two moments, you can use that time to determine the power, because you can figure out the impulse. And what Imamura's research focused on was, he basically said, if you know the impulse, then you know the power output. And throws with higher power outputs are called power throws. So in Imamura's essay, they looked at 3 different throws, Osotogari, Harai Goshi, and Ippon Tsunagi, all done by 5 highly competitive judo pros, basically, for their research. That's who they used. And they did these throws over and over and over again and calculated the impulse at initial contact during the inelastic or elastic collision, and then they looked at the power at the end of the throw. I will finish this slide and the rest of them in the second part of this PowerPoint presentation.